We humans are an ambitious species. We've always dreamed of pushing boundaries, of reaching beyond the familiar. The most audacious dream is to reshape an entire planet. This is the concept of terraforming. Imagine Mars as a vibrant world of blue skies and lush vegetation. The seeds of this concept are rooted in real science. The potential rewards make this journey worth exploring. Before we delve into the hows of terraforming, let's first understand the why. Why Mars? The answer lies in Mars's unique characteristics. It has a similar day-night cycle, polar ice caps, and ancient riverbeds. These similarities make Mars the most promising candidate for terraforming. However, its atmosphere is incredibly thin and composed primarily of carbon dioxide. This thin atmosphere offers little protection from the sun's harmful radiation. Water exists primarily as ice, making Mars a hostile environment for life. Transforming Mars into a habitable world would require a fundamental shift in its atmospheric composition and temperature. The thin, carbon dioxide-rich atmosphere needs to be converted into a thicker, breathable atmosphere with a stable temperature regime capable of supporting liquid water. One proposed method involves the release of super greenhouse gases, such as chlorofluorocarbons, into the Martian atmosphere. These gases are highly effective at trapping heat and could potentially trigger a runaway greenhouse effect, warming the planet and releasing trapped carbon dioxide from the polar ice caps and soil. Another intriguing possibility involves the use of giant orbital mirrors to reflect sunlight onto the Martian surface, increasing solar energy absorption and raising temperatures. These mirrors, strategically positioned in space, could direct sunlight to specific regions, such as the polar ice caps, to accelerate the melting process. While these large-scale engineering projects might seem like the stuff of science fiction, they are based on sound scientific principles. The challenge lies in the sheer scale of these endeavors and the technological advancements required to make them a reality. While the process of terraforming Mars could take centuries, if not millennia, to complete the establishment of human settlements on the Red Planet could begin much sooner. These early Martian pioneers would face the daunting task of surviving in a hostile environment, shielded from the harsh realities outside. Initial habitats would likely take the form of sealed domes or underground structures, providing protection from radiation, extreme temperatures, and the thin atmosphere. These enclosed environments would need to be self-sustaining, recycling air, water, and waste while producing food through hydroponic or aeroponic agriculture. As technology advances and the terraforming process progresses, these habitats could gradually expand, eventually merging to form larger settlements and even cities. Imagine vast, interconnected biodomes simulating Earth-like conditions, complete with parks, lakes, and artificial weather patterns. Life on Mars would necessitate a paradigm shift in human society, fostering a deep connection to the environment and a reliance on sustainable technologies. The challenges of surviving on another planet would demand innovation and resourcefulness, potentially leading to groundbreaking advancements in various fields. Section 5. The Pull of a Different World. Adapting to Martian Gravity. One crucial factor that often gets overlooked in discussions about terraforming is the impact of Martian gravity on human physiology. Mars's gravity is about 38% that of Earth's, meaning you'd weigh significantly less on Mars. But this difference in gravity could have long-term consequences for human health. Studies on astronauts living in microgravity environments such as the International Space Station have shown that prolonged exposure to reduced gravity can lead to muscle and bone loss, cardiovascular deconditioning, and even changes in the immune system. While the effects of Martian gravity are not fully understood, it's likely that humans living on Mars would experience similar physiological adaptations. Whether these adaptations would be detrimental or potentially beneficial in the long run remains an open question. Some scientists speculate that humans born on Mars might evolve differently, adapting to the lower gravity and potentially developing physical characteristics distinct from their Earth-bound counterparts. The challenges and potential consequences of living in Martian gravity would necessitate ongoing research and the development of countermeasures, such as artificial gravity environments or specialized exercise regimes, to mitigate any negative effects. Section 6. Martian Ingenuity. Utilizing local resources for a new home. Establishing a permanent human presence on Mars requires more than just building shelters. It necessitates a self-sustaining infrastructure for a growing population. This brings us to resource utilization. Mars has valuable elements like iron, aluminum, and titanium. Water ice can be extracted for drinking, agriculture, and fuel. The Martian atmosphere contains carbon dioxide for methane-based rocket fuel. These resources could form the foundation of a Martian economy. Section 7. A cosmic balancing act, weighing the ethics and costs of terraforming. The prospect of terraforming Mars raises profound ethical and philosophical questions that we, as a species, must grapple with. One of the most pressing concerns is the potential impact on indigenous Martian life, however unlikely it may seem. While no definitive evidence of past or present life on Mars has been found, the possibility, however slim, cannot be entirely ruled out. If life does exist on Mars, even in microbial form, terraforming could have unforeseen and potentially catastrophic consequences for these organisms. Furthermore, the immense resources and energy required for terraforming would come at a significant cost, both financially and environmentally. Critics argue that these resources would be better spent addressing pressing issues here on Earth, such as climate change, poverty, and disease. The decision to terraform Mars is not one to be taken lightly. It demands a careful consideration of the ethical implications, a thorough assessment of the potential risks and benefits, and a global consensus on the best course of action. Section 8. Beyond the Horizon, Unveiling Scientific Secrets and Protecting Our Own Planet. The pursuit of terraforming Mars extends beyond the realm of science fiction and into the heart of scientific inquiry. The challenges of transforming a planet offer a unique opportunity to advance our understanding of planetary science, climate modeling, and the intricate workings of ecosystems. The process of terraforming would necessitate the development of new technologies and innovative solutions to overcome the unique challenges posed by the Martian environment. These advancements could have far-reaching implications for various fields, from materials science and energy production to agriculture and biotechnology. Moreover, the lessons learned from terraforming Mars could provide invaluable insights into combating climate change here on Earth. By studying the atmospheric processes and feedback mechanisms involved in terraforming, we could gain a deeper understanding of our own planet's climate system and develop more effective strategies for mitigating the effects of global warming. The quest to terraform Mars is not just about creating a second home for humanity. It's about pushing the boundaries of human knowledge and using that knowledge to protect and preserve the only home we have ever known. Section 9. A Martian Legacy. Building a new society on a new world. Establishing a permanent presence on Mars marks a pivotal moment, making humanity a multi-planetary species. This new society would be shaped by the challenges and opportunities of living on another planet. Founded on sustainability, cooperation, and innovation, it would foster a sense of community and shared purpose. Mars could lead to novel social structures, governance, and cultural practices, redefining our place in the cosmos. Section 10. A Future Among the Stars. Is terraforming Mars our destiny? The question of whether or not we should terraform Mars is complex, multifaceted, and ultimately a reflection of our values, aspirations, and fears. It forces us to confront our responsibilities as stewards of our planet, and as explorers venturing into the unknown. Some argue that terraforming Mars is a moral imperative, a way to ensure the survival of our species in the face of existential threats, such as asteroid impacts, pandemics, or even our own self-destruction. Others see it as an act of hubris, a tampering with forces we do not fully comprehend, and a distraction from addressing the pressing issues facing our own planet. The decision of whether or not to embark on this audacious endeavor will likely not be made by a single generation, but rather through a gradual process of exploration, discovery, and societal debate. It will require a global conversation, one that transcends national boundaries and ideological differences, to determine the best course of action for humanity and our future among the stars. Section 11. Conclusion: A Journey of Imagination and Innovation. The concept of terraforming Mars, once relegated to the realm of science fiction, is now a topic of serious scientific inquiry and societal debate. While the challenges are immense and the ethical considerations profound, the potential rewards, both scientific and societal, are too significant to ignore. The journey of terraforming Mars, if we choose to embark on it, will be a testament to human ingenuity, perseverance, and our innate desire to explore and shape the world around us. It will be a journey fraught with challenges, setbacks, and perhaps even failures, but it will also be a journey of discovery, innovation, and the expansion of human knowledge and capabilities. Whether or not we ultimately succeed in transforming Mars into a second Earth, the very act of trying will push the boundaries of our understanding, inspire future generations, and perhaps, just perhaps, reveal to us not only the secrets of another planet, but also a deeper understanding of ourselves and our place